So in this video, we're going to make a start looking at our second family of organic molecules, and that is the family of alkenes. This is unit 2.4 of the CS specification. And as always, on page 1, you have your specification points. So have a read through those to see what we're going to be looking at in this topic and what all we're going to cover. Then on page 2, you have your SIA definitions for this topic. Again, it looks like a bit of an overwhelming list. Maybe have a read through it so you're familiar with these definitions when we meet them. But we will also meet them within the topic, so you don't need to learn them all off by heart now. They might make more sense when we actually cover them within the topic. So what are alkenes? You can see that their name just differs by one letter from alkenes. So there's an E in the middle and not an A. But they're quite different molecules and they react in quite a different way. One thing they have in common with alkenes is that they're hydrocarbons. So again, remember that name means that these molecules contain hydrogen and carbon only. But one way that alkenes differ from alkanes is that they're unsaturated. And that's because they contain carbon-carbon double bonds. So in other words, at least one double bond between two of the carbon atoms within the chain. And that's what we call the alkene's functional group. So the functional group is the carbon-carbon double bond. And that means they're not completely saturated with hydrogen atoms. We said that alkenes were saturated hydrocarbons in the sense that they are bonded to as many hydrogens as possible because they only have carbon-carbon single bonds. And it's this carbon-carbon double bond. It may seem like a very slight change, but it actually makes alkenes more reactive than alkanes, a lot more reactive. So the general formula for alkenes is a little bit different than alkanes because of the presence of that carbon-carbon double bond. It leaves less room for hydrogen atoms to be bonded. And so their general formula is CnH2n. So if you remember, alkanes was CnH2n plus 2, but here we have just CnH2n. So let's have a look at the first few alkenes in the series. Note how the series doesn't begin with methane. So you might have expected it to start with methane because that is one carbon, N equals 1 as such. Ethene is where N equals 2. Okay, and that's still the case because of that little prefix, ETH, it means we've got two carbons. The reason why we have to start there is because in order for there to be a carbon-carbon double bond, there has to be at least two carbons. We can't have a double bond if there's only one carbon atom because it can't be double bonded to anything else. It has to be between two carbon atoms. So therefore, the first alkene in the series is ethene. So what is the molecular formula of ethene? Well, if we put in N equals 2, we're going to have C2, and then it's H2N, so 2 times 2 is 4, so ethene is C2H4. What does the structural formula look like? Well, remember in structural formula, we show the bonds. So what I would normally do is draw your carbon-carbon double bond first, and then draw the rest of the chain if necessary. And then we fill up with our hydrogen atom. So have a look at how many bonds the carbon on the left needs. Well, it needs 2 more. And you can just do them, up here and down there. But to be slightly more accurate, the shape around the carbon-carbon double bond will be like a trigonal planar shape. Remember that double bonds, when determining the shape of a molecule, are treated as single bonds. So you're imagining that this carbon atom had 3 electron pairs around it, and it would adopt the trigonal planar shape. Same on the other side, that carbon atom needs 2 more bonds, so we would put those out like this, and we put hydrogens at the end of them. Okay, I'll do one more example with you and then let you try the rest. Propane is the next alkene in the series, and that's 3 carbons. And so when thinking of the formula, that's going to be C3H6, CnH2n. When drawing the structural formula of this, again, I would draw your carbon chain first. And for this case, we can just draw the double bond between carbons 1 and 2, but it doesn't really matter which way you do it. You can just keep that straight if you wish. That's probably the easiest thing to do in the space that you have here, or you can reflect the shape if you like around that double bond. So there's your chain drawn. And you'll notice the double bond between two of your carbon atoms, not between all of them, just between two of them at this stage. Then we want to make sure each carbon has 4 bonds. So the first carbon will need 2 more bonds. And again, we draw that at the angle of 120, just to reflect that shape. The carbon in the middle already has 3 bonds, so we need just 1 more. And you can draw that at the top of the bottom. And the carbon on the right-hand side needs 3 more bonds. So we draw that at north, east and south. Fill those up with hydrogen atoms. And that's the structural formula of propane. And you can see that it's a gas. So pause the video now and have a go at drawing the rest of those, writing in the molecular formula and drawing the structural formula. So pause the video, draw those in, and then play the video again to check those. So if you have a little check and see that what you've drawn into your notes and written into your notes matches what's on the screen. So butane should be C4H8, pentane C5H10 and hexene C6H12. And it's all about making sure that your carbons have 4 bonds around them, and because these are alkenes that we have 1 double bond within the molecule. And we'll have a look at how the position of the double bond can change and how we reflect the name based on that. But with these, we'll just assume that they're on the first carbon. And you can see the state, what happens to those as we go down the group, as we go down the series of our alkenes. That as we lengthen the chain, what's obviously going to happen is the RMM is going to increase. So just as we saw with alkanes, the boiling point will increase as well. I think that's already in your notes, but if it's not, you can write that increasing boiling point down here. You don't need to know the boiling points off by heart, but you can see that actually the increase in boiling point causes it to change from gases to liquids, and eventually these alkenes form quite waxy solids. So you can see the first 3, ethene, propane and butane, are gases, and from pentane and hexane they're liquids, and eventually they will be waxy solids. So again, it's just due to the increasing RMM. And that's just explained over the page on page 4. Just as with alkanes, the longer the carbon chain, the higher the boiling point due to an increased RMM and greater van der Waals. And you can see the alkanes topic for a full explanation, but it's just that same idea that you met in your intermolecular forces, that the higher their RMM, the more electrons are going to be, so more instantaneous and induced dipoles, which lead to greater van der Waals forces between the molecules, and therefore more energy needs to be put in to overcome those van der Waals, and that leads ultimately to a higher boiling point. So let's now have a look at the rules of naming alkenes. And you'll see that a lot of this is very similar to naming alkanes. It's not that we're learning a completely different set of rules, but there are a couple of extra rules and a couple of things that we need to be a little bit more careful about. So again, I'm going to do a wee bit of colour coding here using my blue, red and green as before. So let's take a quick look through these and explain them, but again, you'll learn them better by just practicing naming alkenes. So the first rule, and you need to be really careful about this rule, is about finding the longest carbon chain. That's always the first step, a bit like it was with alkanes, but there's a slight difference here in that the longest carbon chain must contain the double bond. And so what that means is that the longest carbon chain that you might actually have might not contain the double bond, in which case you don't choose that. You choose the longest carbon chain that contains the double bond, even if that means choosing a slightly shorter chain overall. So if you had 6 carbons in a row that didn't contain a double bond versus 5 that did contain the double bond, you always choose the one that contains the double bond. So the carbon chain that you're picking at the start must contain the double bond. Okay, and that determines the ending of the name. So if it's 5 carbons in the chain, your ending is going to be pentane. Okay, this time we're using the suffix "ine" instead of "ane" just to show the presence of a double bond. That's also to do with our kind of longest chain and the ending of our name. So I'll circle that in blue as well. Okay, rule number 3 is slightly different. It says number the carbons so that the double bond is between the carbons of the lowest number possible. So it actually, the number of the double bond takes priority over the substituents. So say for example, your substituents, you could number them so they were on 1 and 2, but the double bond was on 4, carbon 4. You would not number it that way. You number it the way so that the carbon on the double bond is between the carbons of the lowest number possible, even if that means your substituents are on a higher number of carbon. So that's your priority, putting the double bond on the lowest number. And the number quoted, the locant number as such, of your double bond, the number quoted should always be the lower of the 2 carbons. So if it's between carbon 2 and 3, then the number quoted in the name would be 2 rather than 3. And we'll see that in our examples. Rule number 4 is also to do with the number of chains, so you can circle that in red as well, or the colour that you've chosen. The number indicating the position of the double bond should appear between the prefix that indicates the length of the carbon chain, for example, prop for 3, and the suffix -ine, indicating that it's an alkene. It should be separated from the prefix and the suffix using dashes, because we know that numbers are separated from words by dashes. So if we had but, that means that there's 4 carbons in the chain, and our carbon was between carbon 2 and 3, we would call it but-2-ine. And I've just drawn the basic structural formula of that. There's no hydrogen atoms there, but maybe that will help you see that. So that's called but-2-ine, because the double bond is between carbon 2 and carbon 3. And that's where the number is indicated, but-2-ine. Rule number 5 then, which I'll circle in a different colour, I'll circle in purple, because this is a bit different. It says if more than one carbon-carbon double bond is present, we add the prefixes di, tri, tetra, etc. To the suffix of ine. For example, if we had 2 carbon-carbon double bonds, it would be di-ine. If there were 3 carbon-carbon double bonds, it would be tri-ine. Now, this is where we need to be careful. If there's more than one double bond, we should add an A after the prefix of the carbon chain. Okay, so note an A should be added to the end of the carbon chain prefix if there are more than one carbon double bonds present. So for example, if we had this molecule here, this would be carbon 1, 2, 3, 4. Doesn't matter which way you number it, it would give you the same combination. So the first double bond is between carbon 1 and 2. So we would number that 1. And then the second double bond is between 3 and 4. So we would number that 3. You need to include the numbers of both double bonds in that name. So this would be called buta-1,3-diene. A couple of rules there. So we've got to remember that numbers are separated from each other by commas. Numbers are separated from words by dashes. But we also have a couple of extra things here. Because there's more than one double bond, we need to call this, there's 2 double bonds, so we call it diene. But we also include that little A in there. So rather than it just being but-1,3-diene, it's called buta-1,3-diene. Just another extra rule for you to learn. Okay, so be careful about that one, number 5. And then the rest we've met before. Order the substituents, so they appear in alphabetical order in the name, even if that means you're quoting a higher carbon number in the name first. The substituents always appear in alphabetical order. So if it's ethyl versus a methyl, then put the ethyl first. Okay, and number 7 is to do with the substituents as well. If multiple of the same substituent appear, use the prefixes di, tri, tetra, and so on. And then number 8, as we've already discussed and met with alkenes, numbers are separated from words with dashes, and numbers are separated from numbers with a comma. So lots to take in there, but the main extra rules are just about using ing instead of ine. Finding your longest chain that contains the carbon-carbon double bond, that's really important. Numbering it so that the carbon-carbon double bond is on the lowest carbon over the substituents. The double bond is more important that it's on the lower number than the substituents. And then if there's more than one double bond, you need to indicate that as well, and include a little A at the end of the prefix. Okay, so turn over to page 5 and let's look at a couple of examples. I'll do a few with you and then let you try the rest and we can check the answers afterwards. So let's look at the first one. First step is always to find the longest carbon chain that contains the double bond. Remember that it must contain the double bond, even if there's a longer chain elsewhere. So that's going to go straight through the middle. And there's 4 carbons in that chain, so the end's going to be but. Okay, number the carbons so that the double bond is between the carbons of the lowest possible number. Doesn't matter which way around you number this, the double bond is going to be between carbon 2 and 3. So there's 1, 2, 3, 4. Okay, and there's no substituents here, so we can just jump straight into the name. So that means that it's going to be but dash 2 dash ing. Okay, and you don't have to do that color coded in the name, but it might help you. Okay, so that's but dash 2 dash ing, and it's important that we put the number of the double bond in the name, because otherwise we don't know whether in this example it could be between carbons 1 and 2 or 2 and 3. Let's have a look at the next example. So find the longest carbon chain including the double bond. So that's going to just be straight across the middle. Doesn't matter whether you go up to that wee methyl group there or just straight across. The longest chain is going to contain 5 carbons, so that's going to be pent. And here is your substituent here. I would circle that, I'll do that in green because that's the colour I used for the substituents. Now the next stage is numbering. So previously with the alkanes you numbered it so the substituents were on the lowest possible carbon, but here remember the priority is that the double bond is on the lowest carbon. So if we numbered it right to left, let me just show you this is not the correct way. If we numbered it right to left, you can see that yes, the substituent would be on the lower carbon, carbon 2, but the double bond would be between carbons 4 and 5, so that is not correct. So we need to number it 1, 2, 3, 4, 5, because that makes the double bond between the lowest carbon numbers, and that is our priority. So the double bond is between carbon 1 and 2. So let's, as always, we name our substituents first. They go at the start of the name. So that's going to be 4-methyl. Remember, numbers separated from words with a dash, and that's a CH3 group, which is a methyl group. Then the prefix of the carbon chain is going to be pent. So it's pent dash 1 dash ing. Why it's 1 is because the double bond is between carbon 1 and carbon 2. And so therefore we always quote the lower number in the name. So this is 4-methyl pent 1 ing. So I'm going to ask that you give the rest a go in your notes so that at least these examples are done. So that's pages 5, 6 and 7. So complete those. And then you can play the video again to check your answers. I just encourage you to be really careful of the examples that include more than one double bond. When you get to those, go back to the rules. Look at rule number 5. Give it a go, and if you get it wrong, I'm sure you can change it. You might want to do these in pencil first. It's up to you. But have a go at these pages 5, 6 and 7. Pause the video while you do that. Give them a go yourself, and then check through. You can do one, check one, do one, check one if you prefer, or you can give them all a go and check at the end. So let's try the third example on page 5. So note how finding the longest chain, you could do this if you were finding just purely the longest carbon chain, you might do this because that's 5 carbons. But the problem with that is it doesn't contain the double bond. So we can't do that, we must do this, or you can go from the top down, doesn't matter. That gives us 4 carbons, so that's going to be a prefix of but. Okay, so this therefore is our substituent, and that's an ethyl group. Then we want to number the carbons so that the double bond is on the lowest carbon. So that means we're going to number it 1, 2, 3, 4. So the name of this then, substituents come first. It's going to be 2-ethyl There's only one substituent, so there's no competition with the alphabetical order. And then but dash 1 dash ing. Note how there's no spaces between the ethyl and the but. It's all just one big long name with the numbers separated by dashes. Last example on page 5 then, here's more than one double bond, so you'll get a bit of practice of that. So longest chain is straight through the middle. Number the no substituents, so don't need to circle anything. And then number the carbons so that the double bonds are on the lowest possible carbon. So that's going to be numbering left to right. So 1, 2, 3, 4. There's 4 carbons, so it's going to be but we have more than one double bond. So we need to call this buta, and I'll maybe do that A in purple because that was our rule number 5, the slightly different one. Dash, and then indicate where the double bonds are. They're between carbon 1 and 2, so I number that 1, and then they're between carbons 2 and 3, so I number that 2. Then I put another dash, and then we must call it, and I'll do that in purple because that's part of rule 5, di-ing. So this is buta dash 1, 2 dash di-ing. Again with the next one over on page 6, be careful that you identify the correct longest chain. If you just found the longest chain of carbon atoms, it would be this one, but that does not contain the double bond, so you can't do that. But the longest chain would therefore be through this double bond and up here. That's 5 carbon atoms within the chain, so it's going to be pentene. Circle your substituents. Then number your carbons so that the double bond is on the lowest carbon. So that's going to be 1, 2, 3, 4, 5 this way. And then you have got an ethyl group and a methyl group. The ethyl group comes first because it's alphabetical, but it's also on the lowest, the smaller of the carbon numbers. So that's going to be 2 dash ethyl dash 3 dash methyl. Running out of room here. Then our longest chain is 5, so it's going to be pent. And then the double bond is between carbon 1 and 2, so it's pent 1 ing. Then the next one. Our longest chain is straight across. Number it so that the double bond is between the lowest number of carbons, so that's 1, 2, 3. You've got a substituent here. Okay, and so this is called, I'll maybe not colour code the name from now on just to save us time. It'll be 2-methyl prop 1 ing. On to the next one. Our longest chain is through here. It doesn't matter which way we number it in terms of the double bond. So then we would go to the rule of making sure the substituents were on the lowest carbon if possible, because it doesn't matter about the double bond. So we would number it this way, 1, 2, 3, 4. So then our substituents are on carbons 1, 2 and 3 rather than 2, 3 and 4. So this is a butene, and that's going to be at the end of the name. Our substituents are methyl, iodo and bromo. So we've got to put those in order, alphabetically, not numerically. So the name is going to be 1-bromo, dash 2-iodo, because that comes next alphabetically, dash 3-methyl, and then the ending, which I'll need to move across for, is going to be but 2 ing. Next one then, longest carbon chain right through the middle. It's a bit of an easier one this time. Doesn't matter which way you number from left to right. 1, 2, 3, 4, 5, 6. So it's going to be a hexene, no substituents. So the name is simply hex-3-ing because the double bond is between carbons 3 and 4. Over in the next page, longest chain straight through the middle, or you can do from this one and up to the top if you wish, but that's the longest chain. Number it so that the double bond is on the lowest carbon number, so we will number it right to left. 1, 2, 3, 4, 5, 6. Circle your substituents. We've got 2 methyl groups on carbons 2 and carbons 5. So it's going to be 2, 5 dimethyl. So remember, if more than one of the same substituent appear, we use the wee dimethyl. Okay, and then our longest chain has 6 carbons, so it's hex. Double bond between 2 and 3, so it's 2-ene. So 2,5 dimethyl hex 2-ene. Next one then, move this up slightly. Longest chain straight through the middle. Number it so that the double bond is on the lowest carbon. 1, 2, 3, 4. Circle your substituents, which are our bromos. Okay, those are on carbons 1 and carbon 2. So it'll be 1, 2 dibromo. 4 carbons in the longest chain. And so that is but 1-ene, because the double bond is between carbons 1 and carbons 2. Next one then. We have 2 double bonds in this chain, so we need to be careful about the name. No substituents. There are 2 double bonds and 5 carbons, so it's going to be a pent. And we number it so that the double bonds are in the lowest possible carbon, so we're going to number it left to right. 1, 2, 3, 4, 5. Otherwise, it would be between carbon 2 and 3 and 4 and 5. So this is the lowest possible combination. No substituents, and so it's just going to be penta. Remember the A there, because when we have more than one double bond, you need that little A after the prefix. So it's penta, and then 1, 3. That's where the double bonds are. And then di-ene. And we say di-ene to show that there are 2 double bonds. So be careful about that name, penta, 1, 3 di-ene. Okay, then be careful about your last one, just in terms of chain length. You might be tempted to say, okay, well, there's the longest chain, but it doesn't contain all the double bonds. So we need to go straight across. And then circle your substituents. You've got a bromo here, fluoro here, and an ethyl here. So think about what that's going to be in terms of the alphabetical order. In terms of numbering the carbon chain, it doesn't matter in terms of the double bond, whether you go left to right or right to left. They'll be on the same number of the carbon, but it does matter in terms of our substituents. So if it doesn't matter with the double bonds, then go to the substituents, and that will be a lower combination of the substituents if we go from left to right, because we've got our bromos, 2 bromo groups on carbon 1. So that will be substituents on carbon 1, 1, 2 and 4, rather than 2, 4, 5 and 5. So our name, it's going to be a long one here. So our substituents come first, and bromo is first alphabetically. So it's going to be 1, 1 dibromo. Ethyl comes next alphabetically, so it's 2 ethyl. And then fluoro, 4 fluoro. I'll just go on to the next line, but this should all just be one word. Okay, with 5 carbons in the chain, but there are 2 double bonds, so we need to call it penta. And then they're on carbons 1 and carbon 4. And then we say di-ene. So that should all be one word, but you might not have room to fill that all in on the one line. But it's 1, 1 dibromo, 2 ethyl, 4 fluoro, penta, 1, 4 di-ene. So that takes you to the end of the section on naming alkenes. We'll be applying that to name different molecules within this unit. But for a bit of extra practice, you could try the questions on page 8. You don't have to if you're happy enough with that practice, but it would be good to get the extra practice in these naming these alkenes in particular and drawing out their structure. So if you have a look at question 1, there's just 2 questions, 1 and 2, but with multiple parts. So question 1 gives you what we would call a condensed structural formula of a lot of alkenes, and for each of them you need to write the molecular formula, draw the structural formula and name the alkene. So let me do that with you for part A to show you what to do. Molecular formula is just essentially how many carbons there are, how many hydrogens there are. So if you count up the carbons, you'll see that there are 6. If you count up the hydrogens, there are 12. Do count up the hydrogens, just in case. They should follow the formula CnH2n, and that's if there's one double bond. But you'll see where there's more than one double bond that it doesn't follow that general formula, because you've got an extra double bond, which means there'll be less hydrogens overall. Then draw the structural formula. And that would be the example of the structural formula. In this case, structural formula just means draw it out with all of the bonds. And then finally, name the alkene. And with this example, find your longest chain. There's no substituents. We number the chain so that the double bond is on the lowest carbon. So that's 1, 2, 3, 4, 5, 6. So this is hex 1. Because the double bond is between carbons 1 and 2. So give the rest of those questions a go, and I will upload the answers on Teams for you to check.